The next two are fairly simple examples of just applying a sum and difference identity, or in this case, two difference identities, to prove that the other one is equal on the other side. So, like I said, these go fairly quickly. You can see that this is the cosine of a difference. So to find the cosine of a difference, you take the cosine of the first angle, which is pi halves, times the cosine of the second angle, which is, oops, not alpha, it is x. And then you have to add to it, excuse me, the sine of the first angle, pi halves, sine of the second angle, which is x. The nice thing about the pi halves, if you have pi halves, that angle is up here at a 90-degree angle, or it's a quadrantal axis angle, which means the ordered pair is 0, 1. So anytime we take the cosine of pi halves, this is equivalent to 0 times the cosine of x plus, that's the sine of pi halves is equal to 1, that's times the sine of x, and that reduces to 0 plus sine of x, which is just the sine of x, which is exactly what we were supposed to show that it was equal to. So our mission is accomplished. Like I said, these go fairly quickly. Okay, the second one is the cosecant. Now we really don't have a cosecant one in mind here, but let's see, cosecant is 1 over the sine. So got to be thinking about how we're going to transfer and get that to match up with what we want it to be. So the adjustment we make with this one is, how do we think about cosecant? The cosecant is a reciprocal of sine. So this thing that we're looking at, the cosecant of pi halves minus theta, can be written as 1 over the sine of pi halves minus theta. Okay, so that's what the cosecant of pi halves minus theta would equal. So we're going to first apply a reciprocal identity, and then we're going to try to prove that it ends up being equal to the secant of the angle theta. So all right, we just got to work with this fraction a little bit. So it's equal to 1 over, it's the sine of a difference, so take the sine of your first angle, which is pi halves, times the cosine of your second angle, which is theta. Then subtract the cosine of your first angle, which is pi halves, times the sine of your second angle, which is theta. And we want to prove that that's equal to the secant of theta. Well, the sine of pi halves we just looked at, that's equivalent to 1, so it's 1 over 1 times the cosine of theta, minus the cosine of pi halves was equal to 0, so it's 1, this is all over, so 1 over cosine of pi halves is 0 times the sine of theta, and 0 times the sine of theta is 0, so nothing, we get nothing left on this other side of the subtraction sign, so all we get is 1 over the cosine of theta, and if we use a reciprocal identity, that is your secant of theta. So I kind of did a little, I don't know if I should have done that or not done that, I don't want to confuse anybody, but I first started off, first error here where I probably should have written as 1 over the entire thing. I just want to make sure I don't confuse you by what I kind of did inadvertently. The cosine of pi halves sine of theta. So then I really have a 1 over the entire thing. So this sine of, that's still 1 times cosine of theta, or just cosine of theta. And this is still 0 times sine of theta, so minus 0. So it's 1 over cosine of theta, which is equal to secant of theta, which if I write it like that, even to me, it makes a little bit more sense and a little easier to follow, a little more logical to follow. So, yeah, like I said, those are going to simplify fairly quickly for you. Just apply your sine, your sum and difference identities to sine and cosine. And if you get one of these where they give you a reciprocal, like a cosecant, a secant, reciprocate it and just put it as 1 over your sine of a difference, and then follow through with your rules from there.